This video is going to go into simplifying algebraic expressions. So we're going to look at adding and subtracting, where we have to look for like terms, and then we're going to do some multiplying and dividing rules because they are quite different and need to be looked at individually. So to start with, we'll look at like terms. So this is for adding and subtracting, because just like with fractions where you can't add two unlike fractions without changing something first. So for example, 1/3 plus 1/5, you have to change them to both over 15 before you can do anything. It's a bit like that with algebra. You can only add things that have the same letters raised to the same power. So I've got a whole bunch of different terms here. So we've got 3a, negative 7a, 9a squared, 5ab, 5a squared, and ab. And what we're going to do is, to start with, we're just going to recognise like terms. So they have to be the same letters raised to the same power. So what I'll do is I'll actually circle the ones that are the same. So if we look for the first one, 3a. So what we're looking for is another term that just has an a in it. So if we look at that, it's just negative 7a. The rest, like the 9a squared and the 5a squared, don't have a b, but they're not raised to the same power because they have that squared. So on that, it means that 9a squared and 5a squared are the same because they both have an a that is raised to the power of 2. And then lastly, the other two, 5ab and ab, are like terms because they both have an a and a b that are only raised to a power of 1. So when we go into adding them, and when we start adding and we start doing simple ones, we say to ourselves in our heads, or I say, 3 apples plus 7 apples. 3 apples plus 7 apples is 10 apples. I can't just write 10 because I have to tell them it's 10 apples, so 10a. So 3a plus 7a gives us 10a. And it's the same with subtraction. 9 bananas, take 3 bananas, gives you 6 bananas, okay? Or 9b, take 3b, gives us 6b. So all we're doing is looking at the coefficients, which is the number in front of the letter, and adding or subtracting those. When we move on to example 2, things get a little more complicated because we're now looking at 2 different sets of like terms or potentially no like terms, and we need to know what to do with those. So what I'm going to do first is identify the like terms in the first example. So it says negative 3b plus 2a plus 5b take away 2a. So what I'm going to do is, with red, I'm going to underline the negative 3b, and I'm going to also underline the positive 5b. And there's a reason I've underlined that plus sign that's in front of the 5b. Then I have a look at the other ones, and it's positive 2a, and then we're going to put here take away 2a, and you'll notice again I've underlined that take sign. And the reason I've done that is because that's the sign that you use when you're doing the calculation. So we'll do the b's first. Negative 3b plus 5b, because of that plus sign that's in front of the 5. So negative 3b plus 5b is 2b, because we do negative 3 plus 5. And then we have 2a, so positive 2a, take away 2a, is 0a. Do I need to write 0a? No, because it doesn't change anything. It is just 0. So our answer for the first one is just 2b. When we look at the second example here, we've got 3ab plus 2a take 3b. Now, they all look like they're the same, okay, but they're actually not, because the first one has an a and a b, the second term has just an a, and the third term has just a b. So remember, the definition for like terms was same letters raised to the same power. So none of these have the same letter, which means when we write our answer, if we were asked to simplify this, it would literally be written as it started, because we cannot do anything with this question. Example number 3, we've got 3xy take away 4xy. So firstly, are they the same? Yes. X times y, we've got an x and a y in both of them. So all we have to do is the coefficients. 3 take away 4 is -1. So we would write -1 xy, and hopefully you remember that we actually just write -xy. We don't need to write a coefficient of 1 with algebra. The next one, 5x squared y plus 6xy squared plus 3x squared y. So the first thing is identifying the like terms. So remember, same letters. All three of those terms have the same letters. They both have an x and a y. So that part's ticked off. The second part of like terms is raised to the same power. So the first one, it's the x that's raised to the power of 2. But in the second term, it's the y that's raised to the power of 2. So those first two terms are different. So what I'm going to do is I'm actually going to underline those with two different colours. And then we're going to look at the third term and see if it's the same as one of the previous or whether it's something different again. You can see that the x is raised to the power of 2 and the y is by itself. So it actually matches with the 5x squared y. And then all we do is we add up, because this is all positive, we add up the two green ones that are the same. So 5 plus 3 is 8x squared y plus 6xy squared. And that would be our final answer for that one there. Now we'll move on to multiplying and dividing. So a bit different when we do multiply and divide, because when we just multiply numbers, we can multiply in any order and we still get the same answer. But when we do addition, it's a little bit different, which is why we have to look at those like terms. When we're doing multiplication, we've got 3a times 4. So all that is asking us to do is 4 groups of 3a. If we've got 4 groups of 3a, we're just saying we have 12 groups of a. All we do is multiply those coefficients. So the big numbers is what we're multiplying here. And then when we do division, it's the same situation. This here we've got 10c and we're dividing it between 5 people. So if we want to use a real life example just to connect it to the real world, we can do 10 cents shared between 5 people. We would get 2 cents each. And all we did there was do 10 divided by 5, which is 2. And then we have to, of course, keep the cents there so they know the C. So it's 2C. Then we start to move on to some more difficult ones. So whenever you see a fraction line in algebra, it's always division. So the first thing we do is we deal with the coefficients, the large numbers. 15 divided by 5 is 3. Now, if we have a look at the next part, we've got an A on the top and an A on the bottom, and that's A divided by A. If you divide anything by itself, so 5 divided by 5, 10 divided by 10, 20 divided by 20, they all give you an answer of 1. So what we can actually do is just cancel them out, because we know 3 times 1 just gives us 3. And then can we do anything with the BC? No, we can't. We just leave it as it is. And it stays on the top because it was at the top to begin with. With the second part, when we look at the numbers, we're also, because it's a fraction, we don't always have to do division. It's not always going to give us a whole number. We have to look to see if we can simplify. So 14 over 16 is the same as saying 7 over 8 because 2 goes into both of them. Now we've got a squared. So if we just remember back to what a squared actually means, it's a times a over a. Now if we have something on the top, so this bottom a comes from the bottom there. If we've got something on the top and something on the bottom, we can just cancel them out, which means we're just left with an a on the top, and we can't do anything with the b, so we just leave the b on the top. And again, the c is on the bottom with nothing to cancel with, so we just leave the c where it is. The next one is looking back at doing a bit of bracket work plus collecting like terms once we've expanded the brackets. So first step is to expand the brackets. 3 times x is 3x, 3 times 2 is 6. And now what I'm going to do here is I'm actually going to keep this as negative 3. So when I'm doing it, I'm going to say it in my head as negative 3 times x is negative 3x, and negative 3 times positive 4 is negative 12. Now I get to this point here and I start to look for like terms. We've got 3x and negative 3x. And then these two numbers that are just numbers are the same. So we can keep those. So 3x take 3x is 0x. And positive 6 take away 12 is negative 6. Do we have to write 0x? No, it gives us a 0. So our answer is just negative 6. And then lastly, we've just got another one here. We expand the brackets first, so we get negative 10a take 15, because remember we're treating this negative 5 as negative 5 times 2a is negative 10a. Negative 5 times positive 3 gives us negative 15. Then we're looking at positive 3 times 3a is positive 9a. And then positive 3 times positive 4 is positive 12. And again, we look for our like term. So we've got negative 10a plus 9a is negative 1a, or just negative a. And then we have negative 15 plus 12, which is negative 3. So our answer would be negative a take away 3. Hopefully that has given you a little bit of an insight into how to do like terms, adding and subtracting, and then also simplifying algebraic expressions using multiplication and division.